Hello friends, welcome to this explanation. This is Gaurav Kumar and today we are going to discuss the topic concept of continuum. And as this is a topic most of the students are afraid of, I would like to keep it as simple as I can. The same lecture is also available in Hindi, so if you want to see it in Hindi, you can watch it in my playlist. So let's start with the topic. Friends, in engineering thermodynamics, the attention is focused on the overall or gross behavior of a system. The statistical approach is kept aside and we follow the classical approach. As we all know that we have two types of approaches in thermodynamics. One is macroscopic approach and one is microscopic approach. The macroscopic approach is followed in the classical thermodynamics while the microscopic approach is followed in the statistical thermodynamics. So, in the classical thermodynamics, for the analysis purposes, we assume that the atomic structure of a substance is continuous, and for this we use the concept of continuum. In the concept of continuum, we assume that the structure is free from any type of discontinuity, and we treat that matter or treat that substance as continuous. Right. So, as this is the assumed state, the scale of the analysis is very important. If the scale is very large, then we can ignore the discontinuities. If the scale is very small, then we cannot ignore the discontinuities. So, let us understand by an example. Suppose you have a field, and this field has some potholes in the middle, and you have to go from this side to this side. So if you want to go from this side to this side, you can choose any path. You can go from this path, you can go from this path, you can go from this path, and you are ignoring these potholes. But if the path is very narrow, then you cannot ignore these potholes. Means if you have to go from this side to this side, you cannot go easily. You cannot ignore these potholes. So let us connect this example with the concept of continuum. I am saying if the scale is very large, then you can ignore the discontinuities. Like here we have ignored the potholes. So you can ignore the discontinuities. What are the discontinuities? These discontinuities are mean free path, intermolecular space, the discontinuities of lower order. So if the scale is large, you can ignore them. But if the analysis of scale, if the scale of analysis is very small, very narrow, then you cannot ignore the mean free path or intermolecular distance. So for this case, where the scale of analysis is very small, you have to switch to the microscopic approach. Then you have to follow the microscopic approach or statistical approach. But if the scale is large, then you can follow the macroscopic approach, because there you can ignore the discontinuities. But in this case, you cannot ignore the discontinuities. Right. So concept of continuum is well suited for the macroscopic approach. Let me show you one more example. Suppose we have gas flowing. This is a gas and this is the macroscopic view. If we look at the microscopic view of the same gas, we can see that here we have molecules, and these molecules are not still, they are moving in random direction with different speeds. So they have different intermediate distance, intermolecular distance between them, and one time a molecule is here and one time it's here. So the intermolecular distance are different, their speeds are different, and the space is too large between them. But if we compare this microscopic view with the macroscopic view, here we can see the volume. and this volume as a gross, as a overall, is very large as compared to these discontinuities. And what are the discontinuities? These discontinuities are intermolecular distances, mean free path. So as I have told you earlier, if we have a large scale of analysis, then we can ignore the discontinuities. So here we can see the volume which is flowing as a gross. We can see the volume is flowing, volume of gas is flowing. So we can ignore these molecular discontinuities, and this is what concept of continuum tells us. So what it tells us, that if we have large scale of analysis, or in a classical thermodynamics, we treat the substance as continuous and we ignore the discontinuities like mean free path, intermolecular distances. So this was today's topic, and we will discuss some more topics soon. Thank you for subscribing my channel, and thank you for your love and support. Thank you so much. Have a good day.